Welcome to today's video. By the end of this video, you will have built your own fully functional AI assistant using Python with a sleek HTML or JavaScript frontend. We'll walk you through building an assistant specifically for employees, allowing them to ask questions based on private company data and documents and get personalized, intelligent responses. Stick around because by the end, you will be ready to build production-level assistants that you can use in the real-world applications. If you're new here, don't forget to subscribe for more content like this. Let's jump right in. In this video, we will first cover what OpenAI API is, then we'll cover the core components, then understand what Assistant API is, then give you an overview of Employee Assistant application that we are going to build, and then we'll have a detailed code walkthrough of Employee Assistant. And finally, we'll have a live demo of that application. So what is OpenAI API? OpenAI has released an API for accessing its AI models. It gives users access to all the models such as GPT-3, GPT-4, DALL-E, and Whisper. OpenAI offers these APIs. Completions API. A Completions API is the core API for generating text based on a prompt. It's perfect for tasks like text generation, code completion, and simple chatbots. But it's stateless, and it won't remember any previous conversations. So you can use it when you need simple text generation or basic chat functionality without session management. Next is Chat API. The Chat API builds on completions, but is optimized for conversations. It can handle multi-turn conversations by remembering previous exchanges. However, you need to manage the conversation history yourself. You can use it for chatbots or conversational chatbots that require basic context management across turns. Next is Embeddings API. This API generates vector representations of text, which are useful for tasks like search, recommendations, and clustering. Next is Moderation API. Moderation API automatically flags unsafe content in user-generated text, helping you filter out harmful language. Next, Image API. This API generates images based on text descriptions, which is great for creative applications. And finally, Audio API, which helps you access Whisper, which converts speech to text, making it useful for transcription or building voice-powered applications. So what is Assistant API and how does it stand out? Assistant API is a framework or package which is developed by OpenAI on top of Chat API that enables developers to create complex assistant applications with ease. So when should you use Assistant API? It's perfect for scenarios like employee support systems, customer service assistants, or any situation where assistant needs to be aware of past interactions and offer personalized responses. Let's understand the benefits of Assistant API with this diagram. So assistants have access to all these OpenAI models, and they can call with specific messages or instructions. Along with that, assistants have access to three types of tools: code interpreter, knowledge retrieval, and function calling. Code interpreter can run the code and give the output. With knowledge retrieval, we can give custom knowledge to our assistants. We can add our documents to be used by assistant to give a personalized response. And finally, function calling. So function calling is a way for us to build our own tools or functions that we can call from our application. Next, assistants has this concept of persistent threads. It means that it will persist all the threads, all the conversation that users are having with the assistant. So we don't have to manage the past conversations. It's all taken care of by the assistants. And that makes the life of a developer really very easy. Now let's look at the building blocks of Assistants API. The first object is Assistant. Now the purpose of Assistant is to use OpenAI models and call the tools that we provide to it. Next object is Thread. So thread represents a conversation session between an assistant and a user. Threads store all the messages and they automatically handle the truncation, etc. if the length of the message history goes beyond a certain limit. Third object is the message. A message is either created by an assistant or a user. Messages can include text, images, or other files. Messages are stored as a list in the thread. Fourth object is Run. Run is nothing but it's an invocation of an assistant on a particular thread. So the assistant uses its configuration and threads messages to perform tasks by calling models and tools. As part of Run, assistant appends messages to the thread. And fifth object is Run Step. It's a detailed list of steps that assistant took as a part of a run. There are two ways of creating assistants. You can create it manually from the UI or you can create it using your code. Of course, we'll deep dive into the code, but before that, let's take a quick look at the UI to get a better understanding. Once you log in into platform.openai.com, you can click on Playground, and on the left-hand side, you'll see Assistants. Once you click here, you can see all of your existing assistants and you can create new ones. I have already created an employee's assistant, and that's what you're seeing here. This is the name, these are the instructions for the assistant, and this is the model that assistant is using. And these are the tools that we just talked about. There are 3 tools that an assistant has access to. It's code interpreter, file search, and functions. Currently, code interpreter is not enabled. Next tool is file search, where we can upload files for custom knowledge, and then this assistant will use all of those files to produce the response. And finally, the functions. So we can create multiple functions, we can attach those to the assistant, and then assistant will decide whether to use those functions or not. There are a couple of other model configuration settings here that you can adjust. Once you create it in your UI, you can actually copy this assistant ID from here and make requests for this assistant from your code directly. But of course, that's not what we want. We want full control and flexibility. So we will create the assistant from our code and do everything from there. Now let's build our own employee assistant application. This app will use all of these tools and all the concepts that we have discussed so far, and it will give a clear understanding of how things really work. So let's say there is a company which has number of employees. Let's say company has 2 types of data. One is employees data, which is kind of private, and the other data which is open for everyone, like company documents and policies, which are open to everyone. And now we want to build an assistant application for this company's employees so that employees can ask specific questions and get personalized responses. And we want our assistant application to use both of those data, private and public, along with GPT-4o model to give a final response to the employee. And while we do that, our assistant application should be capable of handling multiple threads, that is, multiple conversations with multiple employees at the same time. And this is how our code would look like. At any point of time, we can have multiple employees having conversation with the assistant. All of these employees will start their conversation on the HTML or JS based UI that we will build. When they'll submit the query, the request will be sent to our backend. The request will be made on /assist endpoint, and our backend will receive the session cookies for each of these users. These cookies will be used to maintain sessions in our server so that we can uniquely identify each session and the corresponding thread getting used for those sessions. In our application, we will have one instance of an assistant. It will be maintained at a global level. Then we will have multiple threads. There will be one thread for each conversation that any employee is having. And those threads will be attached to the assistant. Next, we will create our own function, which will retrieve the private data of that particular employee who is conversing. And finally, we will create embeddings of our company's public data and give our assistant access to those files. Now let's quickly set up our OpenAI API key that we will use in our project. For that, you can go to platform.openai.com, then click on your user profile, go to your profile, click on user API keys, and then click on create new secret key. You can give whatever name you want and click on create secret key. And this will be your secret key that you can use in your code to make requests to OpenAI. Now let's start building our project. Let's first set up our environment. So I'll create a new file called requirements.txt and put all the dependencies we need for the project. I'll start the terminal and activate our virtual environment, and then install all the dependencies. You can also install all of these requirements by running the command pip install and all these packages. So we need a couple of files here. app.py, assistantmanager.py, threadmanager.py, and employeedata.py. Along with that, we will need a template directory that will contain index.html. So index.html will be our UI. App.py is our main Python file that will contain our server code. Assistant manager will contain the code to create our assistant. Employee data will contain the function to fetch employees' private data. Thread manager will contain the thread and run logic. Let's start by creating our server endpoints in app.py. So this is our app.py. We will import OS, Flask.env, Assistant Manager, Thread Manager, and OpenAI. Next, we will load the environment variables. We need two environment variables. One is the OpenAI API key, and the other is the secret key. Let's create our .env file as well. And here we need to add two things, secret key and OpenAI API key. OpenAI API key is the key that we created some time back in OpenAI, and secret key will be used to encrypt the session cookies. You can create the secret key using this code. For now, I'll just comment it out because I already have the secret key. Next, we will create two endpoints. First endpoint is just slash, and it will render our index.html. And the second endpoint is /assist. So whenever a user sends a message from the UI, they'll be making a call to /assist. Now let's build our assist endpoint. So first we need to fetch the query that is sent in the request. Then we need to create a thread manager. If the thread already exists for this particular session for this user, we will not create a new thread, instead use the existing one. And after this, we will add the message that we received from the user to the thread. And after this, we will run the thread. So we will create this run assistant function inside thread manager. We will call this and we will pass the assistant ID and the instructions, and then return the response that we receive from this run. And this summary will be shown in the UI to the user. Next, in the main function, we will first create an assistant manager. Then we will create embeddings of our document that we want to use as an external data for this assistant. So we will first create a vector store and then upload the files and add them to the vector store. For that, we will use the function vectorstores.filebatches.upload and poll. So upload and poll will upload the files, and along with that, it will poll for the status. So once the status is completed, the control will come down here, and we will update our assistant to use file search as one of the tool, and we will pass the vector stores ID over here. Now I have created a sample document for this purpose, organization info.txt. So this document contains detailed employee benefits, their career growth paths, and role transition process. And there are multiple role types along with multiple locations. So assistant will try to find relevant information in this doc while responding to the user. And after updating the assistant, we will run the application. Now let's create our thread manager class and define all the functions. So this is our thread manager class. We're importing OpenAI time, JSON, Flask, and then we have these three functions. First function is create thread. Now this function will check if we have already set the thread ID in the current session for the user who has made the request. If no such thread exists, then we will create a new thread and save that thread's ID in the current user's session. If the thread ID is already set, we will use that thread ID and retrieve the thread using this function. Next function is add message to thread. We use client.beta.threads.messages.create. We pass the thread ID, role, and content, and it will add the content with this role to this thread. And the most important function here is run assistant. It will do a number of things. First, it will create a run for the thread for which this run assistant function was called, and we will pass the thread ID and the assistant ID. And as you know, the thread contains all the conversations along with the user's message that we just received. Now the create and poll function here will not only create run, but it will also poll for the status. And it will wait for it to either complete or fail or transition to require action state. So here we will check if the run's status is completed. If it is completed, then we will read all the messages from the thread, create a summary, and return it from here to be displayed in the UI. Now if the status is not complete, then it may be in the state requires action. So here we will loop over required action .submit tool outputs.tool calls. So tool calls will contain all the functions that we need to execute along with their parameters. So we will loop over all of these tools and one by one execute each tool. If the tool's function name is getEmployeeData, then we will call the getEmployeeData function and we'll pass the employee ID and get the output. And then append this output in the tool outputs. Once this is done, we will check if the tool outputs is non-empty. If it is non-empty, then we need to submit the tool outputs back to the run. For that, we will use the function threads.runs.submit tool outputs and poll. Now submit tools outputs and poll will not just submit the tool outputs, but it will poll as well. And it will wait for the state to either transition to cancelled, failed, or completed. And here we'll pass the thread ID, run ID, and the tool outputs that we created here. Once this is done, we will check if the status of the run is completed. If it is completed, we'll fetch all the messages in the thread, create a summary, and this looks and send it back to be displayed in the UI. Next, let's complete our assistant manager. So here we have two functions, init and create assistant. Init will first check if we have an existing assistant that we want to use. If yes, we retrieve the existing assistant and save it in the context. If we don't have any pre-existing assistant, we create a new assistant by calling the function create assistant, and we pass all these parameters: name, instructions, and tools. Create assistant will receive these arguments and it will call client.beta.assistants.create, and it will pass the name, instructions, tools, and the model to create the assistant. Once it's created, it is saved in the context. Now, one thing to note is if you run this application again and again, and if you don't give any assistant ID over here, then new assistant will get created every time you run the application. If you want to avoid that, you can hardcode your assistant ID over here. Now let's complete our employee data.py. So I've created this very simple function called getEmployeeData, and it will return a fake employee data. In the production application, you would want to make an API call to your database and fetch the data from there and then return it from here. But for this sample application, I'm just faking the employee data and returning it from here. Now to summarize, when we receive a request from the user on /assist, we'll read the query from the user, then we will either create a new thread or use an existing one. After that, we will add this new message to the thread, and then we will create a run for this thread. And then assistant will work on this query on this particular thread to create a final response. Assistant will use that data from the functions, and it will use the data in the files that we uploaded initially. And it will send all of those to the LLM to get a final response. And then we will display the final response in the UI. Now let's complete our index.html as well. So I got this very simple HTML code from ChatGPT in like 2 minutes. Now to run this application, you can go to the terminal and run python app.py, and it will start your Flask server. Here you can see the server is now running on HTTP 127.0.0.1 at the port 5000, and you can open it in the browser, and this is how it looks like. Now in the UI, I will put this query as a user: what is the salary range for my position and what are the career paths for me? And I will give a hypothetical employee ID. Ideally, in a production application, employees would have logged in into the application and your application would have the employee ID that would be passed in the request. And I'll click on assist me. And now it has sent the request to the backend and it's waiting for the response. Now let's look at the logs in the backend. And here we can see requires action. It means that assistant was waiting for an action from our side, and the action was executing getEmployeeData function. So we executed that and we got this as the response from that function, and we updated our thread with this data and submitted the run back for the assistant to run. So this is the tools output that we got. And finally, assistant used the file that we submitted initially. So here you can see the file ID and the text that was relevant. And finally, it returned the response from here. So if we come back to the UI, we can see the response. It's $90K to $130K and 2 to 10 years. Of course, we don't want this and we can remove it. We can reformat it properly. Let's ask one more question. So this is the file, and let's say I'm looking for all the benefits I'm getting for my location, and I want to list down my locations and details as well. So let's ask that here. list all my benefits along with my city name, salary, and joining date. And in the backend, you can see all of these logs, and you'll be able to see all the citations and all the text that is being picked up, which is relevant to our query from that doc. It will send all the data to GPT-4 and we will get our final response. City is San Francisco, this is our salary, and these are the benefits. So this is pretty awesome, right? Now to implement more advanced features, you can go through this OpenAI documentation. You can explore the file search, code interpreter, and function calling. If you go to file search, you can see all the instructions on how to use, how to upload the files in the vector store and then attach them to your assistant or the thread. You can either create the run with streaming or without streaming. The one that we used in our application is without streaming. You can go through this code to get more idea on how this works. Similarly, you can go to function calling and you can find the code on how to use and implement it, both using with stream and without streaming. I hope this video was helpful for you to understand the concepts of OpenAI assistants. If you have any questions, please let me know in the comments. And if you want me to cover any specific topic, please put that in the comments. Thank you for watching and see you next time.